Oi, too noise, too noise. Put the microphone in off, please. Entonces, the equation of the plane is given is ax plus by plus c equal d. And also the coordinate of the point is given. I want to call x1, y1, z1. This is information is given. I need to find the distance. This distance I want to call capital D. This is my goal. Okay. So I say to find that, you try to determine one point on the plane. Okay, I call Q. This point is, for example, is the coordinate I call is x null, y null, z null. It's relatively easy because this is completely, they are infinity possibility. And so you, for example, you select x0. There's one way, y0, and you find the z. Oh, sorry, z, I forgot z here. And you find the z, que is d over c, no? Numerical value, right? You have the point. This is x null is 0, y null is 0, and z null is 0. Oh, no, that is 0, 1, 2, 3, arbitrary. When you have these 2 points, you can determine the vector in between 2 points. For example, QP vector. Now I want to find the distance, and the distance is the segment. Okay, entonces I need to take advantage projection. Es obvio que, okay, the information that we have is the univector, no? The univector of the plane, the univector, okay, the univector, by the way, is the vector A, B, C. So only take the coefficients in front of the variable and the standard equation for the plane in algebra, and this is the vector. So if you are doing the projection, of the vector QP onto the direction M, and remember to find the projection, the only thing you should do is, well, do the, in this case, is horizontal projection, no? Because the blue segment is parallel to the green vector, ¿no? Que es el normal vector. Entonces, perform QP, dot product, normal vector, bueno, uninormal vector, so it's normal vector divided by magnitude of normal vector. And that's it. And this is my formula. No, I want to put a more elegant way, but this is concept. So no, suppose you forgot the formula. Okay, no problema. Entonces you're using this idea, that's it. This idea always works. Okay, suppose the vector QP is subtraction de components, subtraction. X1 minus X null, comma, Y1 minus Y null, comma, C1 minus C null. This is the vector, this is the formula that we're using always when you want to find the vector in between 2 points. Now, perform the dot product, for example, QP, dot product, capital M, after you divide by magnitude. Entonces es basically you perform the dot product between this vector and this vector together. Entonces es obvio que es A multiplication by the first component plus B multiplication by the second component plus C multiplication by the third component. If you want, for example, remove the parentheses. Okay, I am doing that. But I know that the point Q belongs to the plane. So this point Q satisfies perfectly this equation. Okay, so si I plug in the component, I saw que A, X null, plus by null plus c null is equal to D. Entonces you see que this guy, and this guy is this. And it's equal to D. Okay, entonces you replace ax1 plus, I forgot here, 1. This is 1 also. 1. by1 plus z1. And this together is D. This is minus D. Of course, the actual value, no? Because sometimes the cross product, the dot product give me positive or negative, depending. But no, como it's the distance, we are talking about this time, you compute the actual value. So finally, if you divide by magnitude of the normal vector, okay, the magnitude of the normal vector is square root a squared plus b squared plus c squared. And this is my famous distance. Okay, so we can do that using that formula. Okay, super easy. It's just the formula for the horizontal projection, no? Oh, this new formula, que is a particular, que in every book you can see about the distance between the point, one point, and the plane. Do you understand this or no? This is confusing or is clear? Clear? Come on, I want to hear your opinion. Oh, there are a lot of students. Amaury. Okay, another student que I never say your name, so I don't know how I tell the attendance, que es GU. GU because it's guest. You need to fix it that, okay? Non in name. You put your actual name because I need to take attendance. Alejandro, David, Jocelyn, Jennifer, Daniela, Marco, highlight 4, Daniel Gonzalez, Fiddy Edward, Daniel Giraldo, Ricardo, and Leonardo. Okay. Okay, entonces, everything okay? Yes or no? Answer me. Yes, no? Yes, okay. By the way, mister, what's your name? Guess 1447. What is your name? David Restrepo. Okay, David Restrepo. Okay, let's see example. All good, yes, okay. Let's see example, elementary example. Suppose we have an example of this part. Example 1, maybe I call. 1 point is given, P is given, que es 4, negative 4,3. And one equation of the plane is given, 2x minus 2y plus 5z equal negative 8. This is information que es given, entonces the question say find the distance. No. Okay, I immediately using that formula. The formula is easy, look. The distance is equal, you open actual value. Actual value A is 2. Look, this is A, 2. Multiplication by x1, f4. Plus B is negative 2. Multiplication by the next component is negative 4. Plus C, que es 5. Multiplication by the third component of the point, que es 3. Minus, minus D. Pero D es negative 8, ¿no? Entonces es positive 8. Double negative become positive. Divided by the magnitude of the vector, que by the way, the normal vector in this case is 2, negative 2,5. Entonces es 2 square plus negative 2 square plus 5 square. Okay, entonces just arithmetic. And this in the top we have 39, and the bottom we have a radical 33. Leave it like that, or rationalization. Either way, this is not important. And you put approximation, so you want to have ideas on what the actual distance is. 6.789. End of story. Any question? Distance between the point and plane. Okay. Super easy. For us, of course. Because little by little, you understand the geometry in 3 dimensions. Okay, now I propose you another situation. Similar, very, very similar. Distance between two planes, two parallel planes, of course, parallel planes. Suppose this idea. We have two planes. One plane, P1, another plane, P2. How you prove? Well, the equation for this plane is, suppose is AX plus BY plus C equal D. Let me call the, well, this, let me call this two plane. This is one plane I changed in my paper. This is D2 because associated with the two, and the equation for this. Okay. How you prove that they are parallel? Boom. One. Okay. If the normal plane is a normal plane N2, and this is the normal plane N1, are parallel. Therefore, these planes are parallel. So the reference that you take to see the plane are parallel is the normal vector. Now the equation for the second to see the normal vector N2 is AB and C. Okay, suppose that the other plane is AX plus BY plus DC equal D1. And so the only difference is the same normal vector, or probably proportional, you know? Because it's parallel ABC. Okay, not necessarily the same number ABC, but proportional. So you multiplication by 2 or by 3 by a scalar, you have parallel normal vector. Okay, so now what is the idea? The idea is you take one arbitrary point on the plane. Let me call A. And this guy is x1, y1, c1. And you take another arbitrary point B on the plane, the component x2, y2, c2. And you determine here a vector in between 2 points. The vector in this case is the vector AB, no? AB vector. Okay, AB vector super easy. Is again the famous formula of the vector between 2 points, that is x2 minus x1, y2 minus y1, c2 minus c1. The vector. And by the way, I suppose that the normal vector is M, que es the same, because they are parallel, at least proportional. Doesn't matter que es this. Si es proportional, es the same. Es parallel. Entonces es, suppose que es A1, BC. And you perform, why not, again, the dot product. Because the distance I try to looking for is that distance. Let's distance, this distance. 90 degrees here. Capital D. Now this distance is parallel to the normal vector. So one more time, we're using the horizontal projection. And the horizontal projection is equivalent to, say, dot product. Now you perform the dot product between A, B, dot product M. And when you perform this dot product, is a times x2 minus x1. It's a 1 here, I forgot. Plus b times y2 minus y1. Plus c c2 minus c1. Okay, and you remove the parentheses, ax2 minus ax1 plus by2 minus by1 plus cc2 minus cc1. Okay, entonces this guy, and this guy is the plugging in this point into this equation. Entonces es obvio que es D2. D2 que es subtraction, the number and the right hand side for the equation of the plane. No? Likewise, this and this and this is just plugging in this point into the equation for the first plane. So this is just D1. Wow. It's D2 minus D1. Basically subtraction, this minus this. Entonces, bueno, no, this is the top product, but I need to find the projection. Entonces, to find the projection, you need to divide by the magnitude of the normal vector, no? And then the magnitude of the normal vector is square root a squared plus b squared plus c squared. End the story. This is the formula. This is a formula. This is a formula. Or this is a formula. Some people do not prefer memorize formulas using the concept of the projection, you know. And one other people that believe, do lie, using the formula, so you're using that part. Okay? Is it clear or confusing? One more example. One more example of the parallel plane. I have here one. Suppose this. Suppose this example too, no? Suppose we have two planes, 3x plus y minus 4z equal to, and we have another plane, is wow, it's the same. No, it's not the same because the number here is 24. Okay. Yeah, you want to find the distance. Well, okay. I discover in this example, we'll find the distance in between this plane. Entonces I know que the normal vector is the same for both x3, 1, and -4. Okay, entonces according to this formula, the only thing you should do is subtraction. So, okay, I forgot in the formula to put absolute value. It's obvious, right? Because you're subtracting 2 minus 24 or 24 minus 2, I don't care, it's 22, basically, right? That's the formula. The distance is subtraction. You're subtracting the d in the plane, que es 24 minus 2 or 2 minus 24. It doesn't matter because you find the absolute value, the answer is 22. 22 divided by something, divided by the magnitude of the normal vector, que es square root 3 squared plus 1 squared plus -4 squared. This is 26. Okay, entonces now, that's it. I finished. If you want the exact answer, and I don't know, si my lab one like that, or rationalization, doesn't matter. You suppose que my lab accept this answer. However, if you have some idea, physical idea, you put in the calculator, the answer is 4.31. Done. Final answer. Any question? Any question? This distance between one point and the plane, and distance between two planes, two parallel planes, of course. The distance between no parallel plane is 0. No, all clear. Ricardo dice, no, all clear. Suppose that the plane is no parallel. Bueno, entonces the distance is 0 because the plane intersecting, and the intersecting is a line that we see before this example. Any question? Okay. Okay, entonces I bring, bueno, I suppose que it's the last problem of this case. Basically, we have a plane. You can tell right off back the how can, okay, what is your question? Si es no parallel. Two plane no parallel. Two plane no parallel, I suppose que intersecting. How can tell immediately if they are parallel? Well, no, you checking the fantastic proof. The fantastic proof que two plane are parallel is because the normal vector 1 is parallel normal vector 2. You prove somehow this, okay? And you know how you prove the two vectors are parallel. Okay, this is, si the normal vector parallel, entonces the conclusion is the plane are parallel. Para plane 1, parallel plane 2. Si this is fail, bueno, entonces es intersecting plane. Now, the problem is now analyze one plane and lines. Suppose the same plane, I copy 3 times. So we have this possibility, one line, whoop, bang. This is a secant line. Because touch here in one specific point. We have, for example, parallel line, que is never touch the plane, and coincident. Coincident is exactly the same. Coincident. How you determine the location, no? What is the possibility? Si es secant, es parallel, or es coincident. Okay, it's easy. You take, for example, the direction vector of the line, B. You take the normal vector of the plane, M, and you perform the dot product, B dot product M. See, the answer is 0. Bueno, it's because they are perpendicular, no? Orthogonal. Therefore, o es paralelo o es coincidente. So this indicates que es this case or this case. The most frequently case is que no. B dot product M is not 0. And now it's secant. Okay, this is one possibility. Guys, this problem we can solve it in different way. You need to use only your imagination. So there are no infinity possibility, but there are several ways, several paths, several approaches, several methods to face one problem in 3D. Okay, another is you have for example, you have the collection of the parametric equation for this line, no? I suppose it's given, no? It's given. What information is given? Well, it's given the equation of the plane. E, of course, is given the parameter, the set of the parametric equation, no? Of the line. So we can, for example, we can, okay, one expression, we can put together intersecting, suppose intersecting, you replace, okay, this X you replace here, this Y you replace here, and this Z you replace here. Of course, the parametric equation is a function only of T. Okay, and in the example you see details, no, but I try to discuss in the general strategy. Entonces, you solve for T, you have, in this case, when you are doing the substitution X, Y, and Z with the parametric equation of the line, we have one new equation, and this new equation have only one variable, que es T. And so you use isolate T algebra, elementary algebra, and you get T equal to, wow, entonces we have a common point, a secant, and if you want to find the famous point here, you replace 2 in each equation of the parametric line, and you get the intersecting point. Suppose que, okay, I don't know anything, I try to do my best. However, when I find the new equation here, in this case, for example, parallel, I have a contradiction, 3 equal 2. Okay, you know, in algebra, in elementary algebra, we have 3 kinds of equation. The regular equation, the standard equation que I saw every day, que is suppose 2t plus 3 equal 5. And you solve for t, no? But we have another kind of equation like that, 2t plus 3 equal 2t plus 5. When you try to solve this equation, it's obvious that we have no solution, no? Because this is cancelled out and 3 equal 5. It's totally false statement. That means that we have no common point, and this is the case of the parallel. Well, but we have another possibility, que es new equation, suppose new equation, que es 2t plus 3 equal to t plus 3. Wow. Entonces, this is 0 equals 0, no? This is the identity. This statement is true, and that means that the plane and the line are perfect coincident. It's the same. Okay? But this is the most common case, the secant. Okay? Do you understand the idea? Let's go to the example. And I propose one approach to find, for example, suppose que secant, que is the most important scenario. I need to find the projection of this line onto the plane. Okay, so we have the original line in black color. I need to find the new line I want to call S. I call S because it's like the shadow of this onto the plane. Okay, there are many approaches. For example, you pick points on the original line, and you projecting down onto the plane using the formula. And when you have 2 points here, you determine direction vector, and 1 point give me the line. It's a one possibility, no? I'm using another possibility in the example. Okay, everyone follow me? Do you understand the goal I try to find? Okay, suppose now we have a line is given in parametric equation. X equal, okay, so far so good. Okay, minus 1 plus t. Y is equal 1 plus t, and c is 3. Okay, this is the information for the line in the problem. We have a plane. This is the line. Plane. This is the 3 equal indicate identical. The plane is 2x plus y plus 3z equal 5. Okay. I can see clear like water. For example, 1 point P on this line is -1, positive 1, 3. Okay, I suppose at t equals 0. Okay, it's -1, positive 1, and 3. I declare this is the easy way to find 1 point on the line. Well, we can use it equal 1, 2, 3, 4, 5, but I like 0 because it's easy, no? And the direction vector is the vector 1, 1, 3. You see? Sorry, it's -1 here. -1. But wait. No, it's 1, 1. Sorry, carajo. Okay. Erase. Okay, the direction vector is obvious que es the coefficient from the t, que es 1, 1, 0. 1, 1, 0, because in C we have no t. Okay, es 1, y es 0. This is the direction vector. Super. This is the information. Remember, the 2 pieces of information we need to define a line is a point and the plane, and the direction vector. And the plane, the most important is a point I can find. Why not? evaluating any point here, x0, y0, and isolate the c as a point, but no, it's okay. And the normal vector in this plane P, pi, is 2, 1, 3. Okay? Okay, entonces I propose you determine si this line and this plane are secant. So this is secant line or no secant line. Okay, entonces I propose you the easy way, in my opinion, is you take the equation of the plane and substitution x, y, and z into the equation of the plane. I try to discover the t-value, si existe o es contradiction o es infinite many solution, o sea, es identity. And I indicate the position in between the line and plane. Okay, es tu paréntesis minus 1 plus t, substitution, the x here, this x. Plus y, pero y is 1 plus t, plus 3 times c, que es 3, just 3, no t, equal 5. And you solve for t, this equation. Easy algebra. This is minus 2 plus 2t plus 1 plus t plus 9 equal 5. We combine later. This is 3t, no? 3t because it's 2t, 1t is 3t. Entonces we have 9 and 1 is 10, and minus 2 is 8 equal 5, no? 3t is equal 5 minus 8 is minus 3. Therefore, t is negative 1. See, we get one value of t, only one, unique, is because this line is secant to the plane. Entonces, my sketch is a roughly sketch. No. After you can see in your algebra. Okay, it's a plane, it's a my famous line, boom, touching one point. Here. If you want to find this point, okay, by the way, we have a point here, P. Okay, P, remembers a point on the line, que is this point. Suppose que es negative 1, 1, 3. Entonces I want to find this point Q, but it's easy because the only thing you should do is plug in t equal negative 1 in the parametric equation of the line. Entonces x is equal, so the Q point is equal, x is equal negative 1 minus 1, ¿no? Plus t, pero t es negative 1, entonces negative 1, negative 2. Y is 1 positive, minus 1 is 0, and C do not depending of t is 3. At the point, the famous point Q is the point negative 2, 0, 3. 1. Negative 2, 0, 3. Okay. This is perfect. This is clear. So I propose you one strategy. Okay? Not necessarily the only strategy. I don't know if you agree or disagree, but the strategy is step number 1. This is okay. I in the complicated example like that, I propose you you prepare one algorithm to understand. Step number 1, find Q. I did that. Who is Q? Well, Q is the point that belongs to the plane. By the way, you can substitution this coordinate here, and you get 5. Let me see. 2 times negative 2 plus 0 plus 3 times 3. Should be 5, no? I claim that. This is 4, this is 9, 5. Good. Okay. At this point, belong to the plane and belong to the line, both. You find Q. After, you find one thing, okay, in my mind, I define like a S prime. Who is S prime? S prime is another line passing through the point P. I call S prime. And it's relatively easy to find that because we have a point. The information that we need to define equation of the line is one point is given, P is given, and one direction vector. And the direction vector that I am using is the normal vector for the plane. Okay, we have in my hand the two pieces necessary to define the equation of the any line, que is the point I have in my hand and normal vector. Using this piece of information, you find x1. Okay, let's continue with the algorithm. Number 3 step is find one point I call A, que is the intersection between the new line x prime and the plane. This point is called A. Entonces I have in my hand 2 points on the plane que belong to the famous line I tried to looking for, que is the projection. This line I call S, it's a shadow. So now, you have the point Q and the point A that belong to the line, you find the vector QA, and QA vector is the direction vector of this. And using QA and A or Q, it doesn't matter. So for example, using A and QA, okay, it's the piece of information that we need to define the new line. You get the equation. You get the equation for the S. Do you understand the procedure or no? This is the only way? No. Ricardo said, yeah. This is not the only way. You can use in your imagination and create your own algorithm. Entonces, when you, okay, entonces my recommendation is, Heggie, my recommendation is, you thinking, and you write in one corner of the piece of paper, step number 1, when you find the Q point. How? Well, intersection line and plane. Good. Now, after that, I have in my hand the point P, and I have in my hand the normal vector of the plane to say I can find the equation of the line S prime. When you have this new equation, okay, then I try to find the intersecting point between the plane and X prime, I call A. I don't know why I call A. And when the A and Q, find the direction vector. And using A or using Q, doesn't matter, you find the equation. This is my goal, the equation of the shadow, the projection, the equation of the one line, I call S. Okay, let's do it. Entonces now I need to find X prime. X prime is X prime. Okay, X prime is, well, X prime is in parametric is -1. Well, no. It's XYZ. And the point I have in my hand is P, que es -1, +1, and 3. And I suppose it's a normal vector. Doesn't matter. Don't worry for the direction. See, the direction is up or down. This is not important. Because remember, the line is completely infinity in both directions. So you can assume that this is the normal vector, or so you want to suppose que es opposite direction, it's okay. You change the sign, negative, but no necessary. Entonces, 2t, or I call, well, I don't know, this is totally formal. A new parameter is S. 2s plus 1x plus 3s. And this is the equation for the line X prime. Done. Everyone follow me? Now with the equation of the S prime, I need to find the point A. And the point A is the intersection, so basically is 2, put in the equation of the plane. The equation of the plane is 2x plus y plus 3z equal 5, no? Entonces you put 2 parentheses, -1 plus 2s plus y is 1 plus s, plus 3 times 3 plus 3s equal 5. And you want to find the new value, no, of the parameter s in the point A. Entonces minus 2, remove the parenthesis, minus 2 plus 4s, s, plus 1 plus s, plus 9 plus 9s equal 5. Well, entonces we combine like term. This is 4, 1, and 9, 14. Entonces this is 2, this is 1, and this is 9, it's 8, equal 5. Now 14s is equal 5 minus 8, que es -3, divided by 14, 14, x is equal -3 over 14. And sometimes in this problem, normally the arithmetic is a little bit complicated. You can get, for example, fraction, you can get irrational number. Okay, now, because I want to simplify the thing, I did in my paper, right? If you want to find the famous point A, the only thing you should do is substitution this value of s here. Okay? I did that in my paper. Yeah, I get the famous point A. If you want your verification, no, verification, this calculation. Okay, comma 11 over 14, comma 33 over 14. So what comes from this? Well, substitution here, -1 plus 2 times s, que es -3 over 14. And give me that value. And substitution in the second, give me the second component, and so on. Okay, super. Now, using Q point and using A point, I find the famous QA vector, que es our direction vector, ¿no? It's our direction vector. Entonces, super easy subtraction the component, no? I did that. I skip the arithmetic part, guys. 4 over 7, comma, 11 over 14, comma, -9 over 14. Okay, and so finally, see, I have a point A and the vector Q. Entonces, the equation of our projection line is que es equal x, y, z. X is, well, x -10 over 7 plus 4 over 7. Entonces I call in the original line the parameter t. I call in the auxiliary x prime, I call the parameter s. Now here I call the parameter lambda. Okay, this is totally formal. If you want, you put t in every equation, it's the same, but it's different t. But no, it's okay. I take, to form the first parametric equation, you take this component, bang, this is this, bang, and this is this, bang, right? And the parameter is lambda, in this case. The second is 11 over 14. In this case, a coincident, plus 11 over 14 lambda. And C is 33 over 14 plus, minus, it's minus because it's minus, look, minus 9 over 14 lambda. And that's it, I finished. Okay. However, my recommendation is, when you are doing one problem like that, you try to do step-by-step in the paper and step-by-step in GeoGebra to verification everything is okay or no. Okay, let me try to show you one. Okay, let me try to share screen to GeoGebra. Switching. There you go. Boom. Boom, boom. Okay. Do you see GeoGebra? Do you see or no? Okay, yes. Look. Look. This is the original information. We have a plane, the blue plane, and the line black. Es obvio que sí. And remember, we determine no. You see, you determine the point P, bang, que es the point totally outside, no? The point P. And after you determine the point Q, I don't know why I call B here in the GeoGebra, que es this point, que es the intersecting point. Look, you see that? Okay. Now after that, you determine the equation for this, que es this. This is S prime, bang, X prime, line. Now determine the intersecting between X prime and the plane, que is the point, the famous point A, boom. Now using Q, okay, in this case you see B, but E and B and A, whatever, you determine the projection line. Okay, so everything matching good. I am happy, no problema. Okay. Do you see that? Any question, guys? Easy, or complicated? Come on. Any opinion? Do you see my face or no? Okay, let me switch into the whiteboard. Okay, whiteboard. Okay, whiteboard. I see you. You see my face. Okay. Let me try. And the email, I send the link for the Skype. I send one PowerPoint. Do you see that or no? One PowerPoint. Do you see the PowerPoint? If you want, open that. Open the PowerPoint in your computer now, because we study the next thing we study is here in the PowerPoint. Let me try to share whiteboard first. Okay, somebody have the microphone open. Marco, putting off the microphone. Marco Morales, putting off the microphone. Okay. Do you see now the whiteboard? Do you see the whiteboard? Yes. Okay. The topic we are discussing right now is about cylinders. So we switch into another kind of object in 3 dimensions. Cylinders and surface. Cylinder and surface. Let me explain the idea of cylinder and surface. Okay, cylinder, when you're talking about cylinders, es no the classical circular cylinder. For example, suppose que in 3 dimensions, I need to do the graph of the C equal 4 minus x squared. Okay, this is surface. This is cylinder. How do you know que one equation corresponds with the cylinder or one equation corresponds with the surface? When the one variable is missing. Suppose. In this equation, you have only two variables. you have only two variables. So y is missing. Y is missing. Y is missing. Y is missing. Entonces, what's going on? What happened in this case? When the one variable is missing, it's because the cylinder. Let me explain it. What is the idea for the cylinder? Suppose in my mind, I want to do the graph of this, but not in 3D, in 2D. In 2D, I propose you x, z axis because y is missing. Okay, and it's obvious that this is one parabola. This parabola up and down because the coefficient in front of the x is negative, and the y and the z intersect, sorry, is 4. So this parabola, the vertex is located at the point 4 here. This is 4 and up and down. And up and down. This is the graphic of the parabola. Easy. We are doing bar analysis. I want to see. This is one in 2D. So you want to see in 3D. Well, in 3D, the situation change. The situation change. So suppose this parabola I put in black color. I want to put in red color like that. Look. This is x, this is y, and this is z. And the verb is missing. This is the cylinder along the y-axis. Get the y is missing. So suppose to understand this. Let me try to do my best by hand in sketch in 3D. It's no good. We have a family, and this is the cylinder. So now, then okay. The most important thing is one equation is given. Okay, you identify a cylinder. Why? Because one variable is missing. And you are doing one thing. It's called traces. I want to explain in detail after that. Traces. Traces is like convert my problem from 3 dimension to 2 dimension, and the trace is the planes. You are doing the plane. In this case, I'm doing the trace in which, for example, y is 0. And y is 0 equal to 0 represent the plane, que by the way is the plane xz plane. So the picture is look. You see que es parábola, ¿no? Pero en 3D es a cylinder because this parabola is extending along the y-axis exactly the same. Because what is the interpretation? The interpretation is always the same. When the one variable is missing, it's because this free variable is all real number. And this is all real number, then the graphic do not depend on y. This is all real number, this is completely extending in both directions. So suppose in the PowerPoint, let me try to open PowerPoint. Okay, in this case, PowerPoint, let me share this screen, the PowerPoint screen. Share PowerPoint. You see the first slider, you see the two examples of the cylinder. Let me try to show you in GeoGebra more example of the cylinder, right? Cylinder. This is a classical cylinder. Do you see the PowerPoint now or no? Please help me. Yes, no, Professor. The PowerPoint you see or no? Okay, good. Jocelyn say good. Okay. In this case, look. Let me try to understand. This is complicated, guys. Don't frustrate for this for 2 reasons. Reason number 1. The only thing you need to know is identify the cylinder or surface. And this is super useful in the other chapter. Okay, remember this is the chapter 1. The chapter 1 is just the foundation to understand the other chapter, no? Then you need to identify what kind of surface, what kind of cylinder, or what a cylinder surface. Suppose, in the first example, is x squared plus y squared equal 4. En 2D es obvio que this is a circle, pero C es missing, así C es missing, C is a free variable, C is already a number, entonces this in 3D you see like a circular cylinder. Wrong. But in the second example, here in the right hand side of the slider, you see y is equal to x squared. Entonces y equal to x squared es parábola. Ese parábola, pero ese parábola en the plane YZ. But it's the cylinder in 3D. Entonces this parábola, you see que es cylinder along the x-axis, que the x-axis is missing. Remember in GeoGebra, the x-axis is in the red color, no? Do you see? Do you see? Okay. Okay, okay. Let me come back to the whiteboard and see another example. How you identification que es cilindro, no? Okay. Another example, whiteboard. Boom. 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 Whiteboard, right? Whiteboard now? Okay, let me erase that one. Cylinder. We continue working with the cylinder. And you identification que es cylinder because one variable is missing. Suppose. Example, maybe 3 cylinder. X times Z equal 1. This is also cylinder. Why? Because we have 2 variables. 2 variables indicate automatically cylinder. Okay, cylinder 2 variable. Entonces, for example, you have some idea by hand or mentally quickly. I make a trace. And this is the axis X and Z, no? Okay, I make a trace. Trace is a plane que represent Y0 in this case because Y is missing, no? Okay, now this is a parabola. No, parabola, no, hyperbola. Like that, hyperbola. Okay, hyperbola. Like that. Therefore, in 3D, this is the little bit complicated for me doing. But in GeoGebra, you can do super easy. So hyperbola. We have one branch of the hyperbola. This is the X. This is the Z. This is the Y. We have 2 hyperbola. The hyperbola contains 2 branches, no? One positive, one negative. And this you continue. Okay, let me use another color, different family of the like that along the Y-axis. Okay, it's super hard doing by hand. However, we can do, of course, using GeoGebra. Okay, I have. Let me try. Okay, one more by hand. Suppose C equal cosine Y. The question is cylinder, yes or no? Of course, cylinder, because only we have 2 variables. X is missing. Okay, how you have some idea how to like this cylinder? Well, this is the Y-axis. This is the Z-axis. This is the X is missing. No, I suppose that X is perpendicular to the plane of the whiteboard, no? I suppose. And this cosine function look like that. Cosine look like that. Cosine oscillating, you know. Okay, and how you can see in 3D? Well, in 3D, This is X, this is Y, this is Z. Okay, now and do in 3D, and 3D is a cosine like that. However, this is a cylinder because it's completely this in both directions, guys, back and forward, along the x-axis, get the axis gets missing. Okay, by the way, x-axis is located here, right? In 2D. This is 2D, this is 3D. Let me try to find one script que I did. Good, Ricardo. Hurricane Shutter. Store panel. Store panel. Store panel. Yes, you are right. Store panel. Store panels. Look like. Okay, let me try, guys, to find. I am totally lost. Okay, example 1. Wait. Let me see. Carajo. Quadri 1. Okay, I suppose it's this folder. Let me try to open. Stone panel, you say. Wow. Look like stone panel. Yeah. Okay, let me share screen with the GeoGebra. Okay. Look. This is the. Do you see GeoGebra now? Do you see yes or no? Good. Look at the stone panel. It's a cosine. Bang, like that, something like that. The most important I need to understand is the shapes, is, do you understand que es cylinder because my equation is Z equal cosine Y, the X is missing, therefore this cosine function, okay, by the way, is something like that, is along, you reply along the x-axis, que es the axis que es missing. Suppose another example, que es the ellipse. Look, it's also cylinder. This cylinder is not circular, it's elliptical cylinder. And this is the hyperbola, like I explained before. Look, wow, what the hell, complicated. Hyperbola, look. But in this hyperbola, the variable is missing is y, this is along the y-axis. One more important, look, this is the parabolic. This is a parabola. Look at the first example that we are discussing, but in 3D look like that. Okay, it's a parabola. You see in the XZ axis, y is missing. Now it's along, this parabola is extending along the z-axis. This is clear or confusing? Cylinder, everyone understand very well cylinder or no? Or you are totally lost with the cylinder? No? Okay, entonces I want to complicate your life when this surface, surface different. The surface is more complicated. Surface is more complicated. Okay, let me try to do my best. Let me go back again to the whiteboard. Okay, whiteboard. Okay, share screen. Whiteboard again. Switching to whiteboard. I suppose in this moment you see whiteboard, correct? Entonces the super fantastic conclusion is when the one variable is missing a cylinder. Now suppose that nobody is missing. No. And suppose that we have what kind of equation like that? Ax squared plus by squared plus c squared equal d. Okay, entonces in this case the identification is all variable is present in the equation x, y, and z. Nobody is missing. but all are positive. And all are square. When this situation happens, I want to show you in a few seconds that this is ellipsoid. 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 No, I want to show you now. Ellipsoid. Let me try, guys, to do my best. Okay, ellipsoid. Let's come back to the PowerPoint. Ellipsoid. Look, PowerPoint. Let me share the screen to the PowerPoint. Okay, ellipsoid look like a football ball, right? Because it's elixir. This actually is elixir, but in 3D, no? It's elixir in 3D. And we have here two examples of the ellipsoid. Okay, look like. And I want to show you in detail after. But no, this is the quick tours for the surface. The first surface that we are studying is ellipsoid, and how you identification this surface ellipsoid. It's easy because every term of the equation is positive, and no variable is missing. It's complete the collection x, y, and z, and everything is square. So when this situation happens, your identification ellipsoid. Bueno, the detail of the center and the dimension for the ellipsoid after we discuss. My goal right now is identification. Okay, identification. Ellipsoid. Okay, ellipsoid. Now, okay, suppose, let me come back again to the whiteboard. Okay, suppose, look, and the second slider, okay, here, we have paraboloid. How you identification paraboloid? Do you see the PowerPoint, right? The third slider. Paraboloid, the identification is clear. Every variable is present. Expressing c, y, and x. But two square and another no square, linear. And when this situation happens, it's parabola, paraboloid. Paraboloid is the technical name of the parabola in 3 dimensions. But you need to know that the variable, que es linear, no square, represent the axis in which paraboloid open alone. Okay, for example, the green one, the first green one, I can see the c square. Sorry, I look like c to the c. No, that's not true. It's a square. I try to type in 2, no z. The green one is c variable, y variable is a square, and x no square. Therefore, this is a paraboloid que open along the x-axis. Bueno, in what direction? Si open in the positive direction or negative direction, depende the sign. Bueno, si es positive, es to the right. Si es negative, to the left. And for example, the second, que es blue, actually it's not blue, it's cyan color. It's again paraboloid, but open in along the y-axis. Okay, remember the y-axis in GeoGebra is the green axis. Do you understand this? Everyone follow me, guy? It's complicated or it's hard? So paraboloid, let me see, paraboloid elliptical, it's elliptical paraboloid. Let me come back to summarize the information that we discussed it, because after I don't remember very well. Suppose. Switching whiteboard. Okay, I need to summarize information because I need to remember very well this. Suppose that we have a x squared plus b y squared equal c. ese paraboloide, ese elliptical. What is the reason que es elliptical? It's elliptical, bueno, it's elliptical when the A and B is different number, ¿no? Si A and B is the same number, entonces es circular. We don't see, okay, sorry. Okay, I don't know why. I suppose you need to see. Now, it's okay. Good. Okay, entonces this is a typical format of the identification paraboloid. Paraboloid is, you have to, one possibility is you have A, x squared plus B, z squared equal y, no? This is another paraboloid, but this paraboloid open along the z-axis. So I suppose the first one is a paraboloid like that. The first one, because it's C, the linear, and this is the Y. So this is another paraboloid like that. Make sense? This is paraboloid. This is the second. Let's come back again to the PowerPoint. In the PowerPoint, this next guy that we study is this. Bang. The name of this figure is hyperboloid of the one sheet. 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 You can see that the identification is clear. For example, you have completed the collection of the variable x, y, and z. No variable is missing. See, one variable is missing is cylinder. Entonces, x, y, and z is present in our equation. Therefore, this is surface. The problem is interpretation. When the one sign is negative, oh no, you don't see the PowerPoint. Carajo. Now, PowerPoint is to see. Good. Okay, entonces now, okay, entonces let's do something. I present everything in the PowerPoint because it's easy, no switching to the other screen, no. And after I try to summarize in the whiteboard, the most important. Okay, this guy is called hyperboloid of the one sheet. And this guy, you see in the equation below the figure, que es x, y, and z is present in the equation. Everything is a square. Good. However, one is negative. See, one is negative. It's the famous hyperboloid of the one sheet. And this hyperboloid open in the direction of the variable que es negative. In this case, the hyperboloid open along the z-axis. Pero suppose que no. Suppose que x is positive, y is negative, and z is positive. So again, so we have only one negative sign in the hyperboloid of the one sheet. And the negative sign identification, que es the axis, que es open the hyperboloid of the one sheet. This is clear or confusing? Guys, now I encourage you que you open GeoGebra. I want to send one script, no? But you feel free to open GeoGebra and type in any equation that you want. No. Of course, we have infinity surface, no, but no. We study the classical, the surface that we are working throughout the course, the most important. No, we have, crazy. Okay, now this is hyperboloid one sheet, but we have another, que es hyperboloid two sheet. Look, boom. Okay, hyperboloid of two sheet. Actually it's no one surface, it's two surface separately. Okay, entonces how you identification? Bueno, hyperboloid one sheet, two sheet, sorry, is x, y, and z is present. is a square also, and only one is positive and two negative. Entonces, now the variable que es positive is identified along what axis is open this hyperbolic, because actually you can interpret it like a two hyperbola, no, in the 3D, but actually surface. For example, it's clear, at least for me, see here. You see que y is positive, x and c is negative. Entonces, this is a hyperbola de two shape que open in the direction of the y-axis, que es the green axis. Okay? Okay, entonces we have hyperbola de two shape. Now, a cone. Actually, it's a double cone. Double cone. The double cone. Entonces, how you identify double cone? Double cone is okay, x, y, and z is present. But one is different sign. So x, y, and z is present in the equation. Everything is a square. Everything no linear, no square, and one is different sign. So you have two negative, one positive, or So this is the variable que es positive identification and what axis is along this double cone. Okay, in this case, for example, in the first example, x is positive, y and z is negative. Entonces, double cone along the x-axis. Okay, not bad. And the last is the weird. Is the hyperboloid parabolic. Wow. Hyperboloid parabolic is very similar to the parabolic, but in the parabolic, parabolic elliptica parabolic, for example, this is hyperbolic parabolic, no elliptic. In elliptica we have plus. In hyperbolic you have minus. Entonces, this is a very weird figure, but I bring one example to illustrate very well the shape of the hyperbolic parabolic, que es the Pringle. The Pringle. Pringle is a typical, in the real life, you see the hyperbolic parabolic, no? Because when you are making trace in one direction, it's the parabola. In another direction, it's a parabola que open up, for example. In another direction, is parabola que open down. Y in another direction is hyperbola. O sea, it's a combination in 3D, parabola, and hyperbolic together. Give me hyperbolic parabolic. Okay? Okay, so let's come back to the whiteboard because I want to summarize everything. Everything, the most important surface. The most important surface que we study in Cal 3. Okay, whiteboard. Do you see the whiteboard? Entonces now, good. Remember, case number 1, ellipsoid. Ellipsoid look like a football. Ellipse in every dimension. Ellipse. Look like a football ball. Paraboloid elliptical is the case 2. Your identification clear because we have a complete collection of the variable, pero one variable is linear, exponent 1. When I say linear, it's because it's exponent 1. Entonces now ese combination parabola en x direction, en y direction, but in z direction is ellipse. So the trace in this direction here is ellipse. Okay. Number 3 is the hyperbolic. The hyperbolic, let me see, hyperbolic, look, is ax squared for example, minus b y squared plus c squared equal d, no? So one is negative, no? Or different sign, no? So this is hyperboloid of the one chip. And this look like that. Shoop, 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 shoop. In this case, is along the y-axis, and now suppose it's x, y, z. I suppose that my hyperboloid look like that. Okay. Along the y-axis is the axis is negative, no? Different sign. However, when you have two signs, suppose ax squared minus by squared minus cz squared equal d, es hyperboloid pero too cheap. And too cheap es la que tu parábola. Something like that, weird. And this is along the axis que es positive. You see, suppose que this is x-axis. Okay? Suppose. Number 4. Number 4 is a cone. In cone, we have, for example, ax squared plus b y squared minus c squared, but the right hand side is 0. This is a super fantastic clue to identification cone. And cone in this case is along double cone, no? Double cone. This is x, this is y, this is z, and double cone like that. Boom, 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 boom. It's along the c-axis because c is negative. Suppose que the negative is located in y, entonces es double cone also, pero along the y-axis. And finally, the complicated guys, que is hard, by hand is for me, it's impossible. Is the, suppose ax squared minus b y squared equal, this is similar to the paraboloid, look, but it's minus, equal c. Okay, entonces this is, look, compare this equation and this equation. So both are paraboloid. The name is the same, paraboloid. But this is hyperbolic. So the adjective is hyperbolic. Because ese paraboloide, because actually es parábola. Suppose doing the trace or doing the intersecting, suppose que y es missing. Es parábola. Ax squared equals z es parábola. Okay, super. Suppose que x is missing. It's another parábola, but up and down because it's negative. And suppose que c is missing. No missing, because missing is 0, is a point. Suppose que c is a constant, 3. This is the equation for the hyperbolic. So basically it's a complicated figure. Que es parábola in one direction, parábola in another direction, but opposite in open in opposite direction, up, down, or right, left. And also is hyperbola in another direction. Okay, quickly. I bring example, pero we are doing together, no? I need participation. For example, suppose x squared plus y squared minus 3c squared equal 5. Bueno, okay. I have no idea. Suppose I want to do. I put in the algebra. I see. Así. However, suppose that we have no GeoGebra right now. I need to only identification. So the question is, what kind of surface it is? ¿Es elipsoide? ¿Es paraboloide, elliptic paraboloide? ¿Es hyperbolic paraboloide? ¿Es... Entonces ahí sí, bueno, the X, Y, and Z are present. Everything is a square. But the Z is negative. Entonces, what do you... please help me to understand this. Es ese con no. It's no con. Why no is no a con? Because con is when the right hand side is 0. Okay, when the right hand side is 0 is a con. For sure it's a con. For sure. See, I put 0 here, I agree with you que it's a con. But it's no con. Because 5, no 0. Entonces another surface. Come on, help me. What is that? What is that? Ellipsoid, no, because ellipsoid, everything is positive. Okay, ellipsoid, no, you are wrong, because ellipsoid is positive, 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 and square, square, square. And when you have only one negative, is, come on, help me. Exactly. Hyperboloid one chip. Hyperboloid one chip. Hyperboloid one chip. One chip. Guys, I don't know if you like or you don't like that part, but you have time. I recommend that you create a GeoGebra 1 account and put the question. You are familiar with this. I love that part. It's easy. It's straightforward, but you need to remember. The thing, the course that I am teaching this class, I don't know why the student don't remember this, but it's super easy identification. Okay? Okay, one more example. Suppose this, to confuse you. X squared plus y squared minus 3z squared. Well, it's the same, but it's minus 5. What do you think? Tricky. I put intentional to confuse you. Professor, you never explained why the right hand side is negative. Well, okay. See, I never explained. You multiply everything by -1. Oh, now it's more clear for me. Entonces, what kind? What kind? What kind of surface it is? What kind? Quickly, identification. Oh, Tucci, hyperboloid Tucci. Because we have two negative. A square, so the feature of the identification is every variable is present in my equation, X, Y, and Z. Everything is a square. Good. Now two negative, Tucci. Along, okay, along, what axis along? O sea, es like two paraboloides, pero no, es hyperboloid to shape. Pero along, what axis, along what axis, along what axis, along what axis, along the sea. Very well, along the sea. Okay, one more example. Suppose this example. Suppose this example, x minus 2y squared minus 4c squared equal to 0. What the hell is that? Well, it's hard. It's hard in that way. So no expect I give you an elegant way. If you, for example, manipulate a little bit, you move the negative to the right hand side, x is equal to y squared plus 4c squared. Okay, good. Now it's more clear identification. What the hell is that? What kind of surface it is? Why? Identification. What is the name of this lady? You see, every variable is present, x, y, and z. Good. But two square and one linear. And it's plus in the square. Entonces, elliptical paraboloide. Yes or no? Elliptical. Exactly, Giraldo. Elliptical paraboloid. Along what axis? Along what axis? Okay, guys. Almost along the x. Very well. Quickly. One more example, and that's it. No, two. X squared minus 4 y squared minus 4 c squared equal to 0. What is that? What surface it is? What surface? Suppose I don't see clear. I multiply by -1 the entire equation. Entonces, minus x squared plus 4y squared plus 4c squared equals 0. Entonces es x, y, and c is present. Everything is a square, but the right hand side is 0. Entonces immediately que ahí sí, right hand side 0, ese con, doble con. Ese con de Restrepo. Pero dice doble con, open, along what axis? Along. Along what axis? Along what axis? X axis. Very well, Daniel. Que es de different. The last problem. I promise que es the last one. X squared plus y squared plus c squared is equal to x plus 2y plus 2c. What the hell is that? What do you think? This is to confuse you, to using your imagination. X squared plus y squared. Okay, x, y, and c is present. X squared is positive. Okay, does it look like what? Come on, guys, help me. When everything is positive, es elipsoide. Okay, es elipsoide, good. Pero much than elipsoide. Much than ellipsoid. It's a sphere. Why is a sphere? Because A, B, and C is 1, 1, 1. It's actually, this is a sphere. Okay? Que es one particular case of the ellipsoid. Super. Guys, time is over. Wait, I want to say all something. Okay? I checking yesterday. Of course, yesterday was Sunday, no? Only 3 students, 14 students already signing in the MyMath, que es el lab online. Only 3 students working. Only 3 students working. The rest no. I repeat again. This problem is not easy, but you count on my help and another professor we have, the tutor. Remember my office hour. My office tutor is tomorrow 1 to 5. Thursday is from 4 to 8. They change a little bit, 4 p.m. to 8 p.m. And Friday was fantastic. Friday nobody is inside the lab. You go inside, ask me any question. Of course, any question about the homework, no? And the pre-test also. But the test, no, never. Okay, guys, enough. Bye. Let me put